technology extends our reach into the world. It gives us access, power, information. That's especially true of technology in this century. Because our technology is more than objects or machines. It's organization, systems.
A technological system would include the automobiles, the roads and highways used by the automobile, the service stations, the gasoline stations needed by the automobile, the traffic lights which control the automobile, and so on and so on. So the system consists of the various components that make it possible, we might say, for the artifacts to fulfill their mission.
I think technology has two components to it. On the one hand, it's the hard artifacts, the machinery. Then on the other hand, it's the way we organize our world. So that tied to technology, I think, is a very, very strong sense of organizing to get something done, hence a very strong sense of controlling.
Early 20th century America was the era of the systems builders. Henry Ford was the most idolized of his time. He came from the tradition of rationalism. Rationalism is the belief that the human mind can discover innate laws which govern the workings of the universe. As early as the 18th century, philosophers believed that the application of those laws could eliminate disorganization and lead to limitless material progress. Voltaire.
Reason and industry will progress more and more, and the evils that have afflicted men will gradually disappear.
The rational method is deeply rooted in our Western culture. For me, it really starts with the Greeks and the idea that you didn't understand something unless you can state it explicitly. Now, if you can state something explicitly, it follows that you can write a law for it or a rule. At the root of it, it seems to me, is the desire to eliminate uncertainty.
Early 20th century America was a place of great uncertainty. Cities were overwhelmed with migrants from the country and immigrants from abroad, all struggling to make ends meet. The nation was in a deep economic slump and was ripe for a revolution. Instead of riots, it got the Model T, the motor car for the great multitude.
Fordism responded to the needs of the time. People were craving for material goods, and Ford provided it for them in an automobile that they could afford and use.
But the Model T wasn't just remarkable for how it changed American life. It was a remarkable piece of technology. Almost every part of the Model T represented an improvement in automotive design. The steel frame of the Model T gave it both lightness and strength. Bumps were never a problem. Sinking in mud was the exception, not the rule. The alignment of the wheels to the frame allowed for extreme turns and good ground clearance. Easy to get out of tight places. The engine block was made from a one-piece casting, and its top, the cylinder head, was a separate cast component. Easy to maintain and more reliable. The T had 2 forward gears and 1 reverse, all operated from floor-mounted pedals. Simple to handle. The Model T was so remarkable that the company could advertise the car to everyone. It was user-friendly technology. But some saw more in Ford than a friendly automobile. The Mexican muralist Diego Rivera painted these murals in 1934 for the Detroit Institute of Art. Rivera featured the Ford River Rouge plant outside Detroit. He painted the workers and the machines they used, not the car.
The Rivera murals talk, on the one hand, about the same kind of exaltation in very sophisticated technological systems that Henry Ford's moving assembly line said to everyone who came to see it. And that is, what an incredible achievement this is. So when you look at the murals, one of the things you see is the wonder of the magnificent machine or the magnificent system. So from one point of view, Henry Ford represents the triumph of rationality over nature, disorganization, old habits of manufacturing, transformer of the world, the bringer of the modern world. He was simultaneously a liberator of ordinary Americans because the Model T could get them around. And he was also presiding over a system so complicated and so intimidating that he dwarfed ordinary people. He represents technology, both as that which helps and that which dominates.
Today, the Ford Motor Company's River Rouge plant is still the largest Ford plant in the world. It employs 10,000 people and produces 90,000 cars and trucks a year. But it's a fraction of its former size. In 1935, it was colossal. It produced almost 2 million cars and trucks a year. It said something about its owner and about what systems need.
Henry Ford was obsessed with control. One of his managers made a decision to start digging the foundation hole for a new building, and Ford came along and said, "I didn't tell you to do this today. Fill it back in." So it was just the right thing to do, but because it hadn't come from his lips, he didn't want it done.
Henry Ford had a need to control other people. And as a result of this motive of his to control, he created an assembly line and a method of production that, in fact, specified and controlled exactly what people were supposed to do. But we should not forget that it was this method of production, besides controlling others, made it possible to produce a car at a low price.
In 1908, the year the Model T was introduced, it sold for $825. The factories made 27 cars a day. In 1923, the year the Rouge was completed, the price had dropped to $395. The plant produced over 2,000 cars a day. Ford reduced the price by creating a totally rational system. Efficiency was all that mattered. That meant control. Control of every aspect of production. Ford didn't want to depend on outside suppliers. So he bought mines and forests in states around the country, rubber plantations in countries around the world, a rail line, a shipping line. Ford didn't want any outside interference with his operation. So he enclosed the Rouge compound with fences and tightly guarded gates. Workers had to use an overpass to enter and leave work every day. It was the scene of many struggles between management and union. Including a violent battle in 1937, which left 4 demonstrators dead and 5 wounded.
One way that you can look at the tough side of the Fordist idea is to say it is called Fordism. That's the personal name of the owner. And it is a statement that says, I'm the boss. You follow orders.
Right, by the left. Quick, march!
Uniformity was the way to exert control over not just the people, but also the product.
Standard design was one of the essential components that had very important consequences as to how automobiles would be built in the Ford factory. What Ford did is that he started out with the principle that his car would be of a standard design. He used to say you can have any color you want as long as it's black. And the idea is that once you standardize the design of the car, you can standardize the entire production system.
This is the Model T the way it appeared in the imagination of Henry Ford and his engineers. An assembly of simple parts into a coordinated whole. Commentators at the time thought the genius of the car was its price, but the genius was really in the parts, standardized parts. The manual was clear. Each Model T had 6 standardized cover plate bolts made of vanadium steel with 3/8-inch threads, 15 cylinder-headed bolts, a standard 2 5/8 inches long, 4 standardized steel spring clamps, strong enough to hold the leaves that supported the automobile. 6 rivets secured the bolts that held the wheel rim. 4 wheels meant 24 standard bolts, 24 off-the-shelf rivets. Putting one automobile together was a bit like following a recipe. To the T. Standardized parts meant production could be repeated over and over. It's because the parts are identical, or at least interchangeable. Almost everything around us is made of interchangeable parts. We just don't see them. Like the fast food hamburger, no longer a recipe, just a set of parts, standardized parts. Each part of the hamburger must meet certain specifications, like fluffiness, freshness, weight and color, thickness. The parts come together to form the American hamburger, just another piece of technology, food technology. But the designers of 19th century technology didn't have fast food in mind, or any other product made of interchangeable parts. Technology for them was an extension of craftsmanship. In the factories of the 1890s, skilled operators could handcraft any part for any machine. They used general-purpose machine tools, like this cutting lathe. These tools demanded skills that took years of training and experience, like superb hand-to-eye coordination. a delicate sense of touch, and an ability to visualize the finished product.
The general purpose machine tool meant that someone would have to make small decisions about they have to read a blueprint, they'd have to mark a part, they'd have to move a part, they'd have to adjust it. There's a lot of, mixes between head and hand.
This 1918 Ford educational film reveals how new tools reduced the need to make decisions or read blueprints. These were single-purpose machine tools, just like Henry's instinct. Craft skills were unnecessary. A sense of touch reduced to repetitive routines. No need to imagine the final product, just do it. Skill was now in the machine. The man just had to be quick.
He would call them farmer machines, meaning that a boy could come into his factory off the farm not knowing anything about building a car. He can learn to do that job quickly because the machine he's using has only one way to operate.
I'll have a big classic double with cheese.
Fast food restaurants don't need employees with cooking skills. They've got their own farmer machines. There are single-purpose machine tools for almost every function in the restaurant. The cash register notes the change needed. A timer goes off when the chili needs stirring, every 15 minutes. Another when the French fries are done, every 5 minutes. When the rush hour is on, the restaurant itself is a machine. This was far different from the late 19th century factory. Workers stood side by side, carrying out unrelated tasks. Experienced machinists decided how the tasks should be done and at what pace. Semi-completed parts lay all around. There was little planning, little discipline, no system. Frederick Winslow Taylor.
Hardly a competent workman can be found who doesn't devote a considerable amount of time to studying just how slowly he can work and still convince his employers that he's going at a good pace.
Frederick Winslow Taylor was born into a wealthy Philadelphia Quaker family. He was expected to enter Harvard, but his eyesight began to deteriorate. Physicians said a nervous condition could be the cause. They prescribed manual labor. At the Midvale Steelworks, Taylor found his place. He carried out what are today called time and motion studies. His goal was to break a job down to standardized parts, a set of rules. Taylor chose a pig iron gang for this, his most famous study. After watching them work, Taylor redesigned their every motion, instructing them when to start, when to lift, when to walk, and when to stop. Their output went up almost 400%. Taylor called his system scientific management.
The system of scientific management is a magnificent expression of obsessional control. For Taylor, it was a perfect kind of work to enable him to utilize his particular kind of imagination, but it also was a perfect kind of work to enable him to
control a lot of the neurotic conflicts that affected him all through his life.
Since childhood, Taylor was tormented by a nightmare in which he was imprisoned by a machine. Only by maintaining a fixed position in bed could he escape it and sleep.
He rigged a contraption to supposedly control the sleep problem. The contraption, he laid in bed and he would sleep on it. It was almost like a bed of nails.
The stopwatch, a more subtle control device, remained the key to Taylor's waking hours. Every job was subjected to its scrutiny and standardized. Taylor compiled hundreds of charts and diagrams that specified those standards and the order in which the jobs had to be done. He put all planning into the hands of managers. Workers would only carry out tasks.
The heart of 20th century American technological system is the idea that there is somewhere or other a group of people, a small group of people who design things and control the operation of the system.
Frederick Winslow Taylor.
In the past, man has been first. In the future, the system will be first.
This is Frank Gilbreth, another management specialist. He went beyond the stopwatch. He used film to determine the most efficient movements. He called them thurbligs, his name spelt backwards. Gilbreth also attached lights to workers' hands and photographed their movements at slow shutter speed. The movements left indelible paths. These cyclographic pictures were made into wire models that could be analyzed and redesigned. Scientific management was applied to everything. Control like this is invisible, not confrontational. The system applies the pressure.
It depersonalizes the authority relation. Therefore, people subjectively, psychologically feel as though they're not being controlled, when in point of fact they are by the subjective system.
It's what happens at Wendy's. When an order is placed, it flashes onto screens in the production areas. The restaurant has a single purpose: to get the order to the customer within 15 seconds. The layout of the kitchen is designed for maximum efficiency. Workers on the line take no more than 2 steps in any direction. And to make it work, customers also have their place.
To tailorize a job like at a fast food restaurant, what you're really trying to do is see what everybody did up till now. Take all the skills that they have and sort of siphon them off and put it into the system. You're working very fast. It is a hard job. No one should ever think that this has become simple because it's tailorized. I mean, you do a lot, and you go crazy from the beeps and the buzzers. But you didn't have to know. It's no longer a matter of his intuition.
Intuition has no place here. It's about predictability, the removal of uncertainty. At Wendy's, every order from the cash register is automatically broken down into reports by the corporation's mainframe computer. It allows managers to monitor food sales, per product, per hour, and to manage employees. 80% are part-time. Their hours can be changed on the day.
When we talk about and think about technology, we tend to think of it as something that's in and of itself. we tend to talk about it as somehow being a passive thing. I mean, and I think the important thing is that people make decisions about technologies. They make conscious choices about technologies.
In early 20th century America, immigrants flooded into the country. These newly arrived forced Henry Ford to make conscious choices. Most came from farms and lacked industrial skills. They traveled to cities like Detroit looking for work. In the first decade of the century, most automobile workers were skilled craftsmen. But there weren't enough to produce the number of cars the big manufacturers demanded. Henry Ford was smarter than the rest. He filled his factories with single-purpose machine tools. He tailorized jobs to remove waste and uncertainty. But even that wasn't enough. The unsupervised worker could still work at his own speed. So Ford took one final famous step. He created the assembly line. By 1914, three-quarters of the Ford labor force was foreign and unskilled. Possible because they were now totally controlled.
One of the last barriers that Henry Ford succeeded in crossing was to get workers to work at the speed that he wanted them to work. And he did that through the assembly line. And that is part of a larger system, I guess we could call it, of materials handling within the factory.
Ford engineers arranged work in logical order, so materials and semi-completed parts mechanically made their way through the plant when they were needed. This meant that every worker was feeding the assembly line and had to keep up.
What he was doing is creating a progressive production system. The idea that work progressed from one point to another to another. I think the best analogy as to what's going on in the Ford factory, which is very, very different from other factories, is the analogy of, small streams and rivers all flowing into each other. The main assembly line essentially being the main river into which all the tributaries flow.
Automation has replaced many workers in the Rouge plant, the same underlying principles remain. Once something as complicated as an automobile could be mass-produced, anything could be mass-produced, giving more people access to more goods. Mass production feeds mass consumption, and mass consumption feeds mass production. The standard of living in the United States skyrocketed over the first half of the century.
If you compare the way the American style of technology allocated wealth and poverty in the United States until about 1970, it's about as good as any other system that's ever been around in history. A very substantial number of Americans had access to pretty darn impressive standard of living, as we usually call it. That's the great payoff of the Ford system.
The Ford system was copied around the world. In Germany, factories produced the Volkswagen, the people's car. It surpassed the Model T as the best-selling car in history. But Ford's legacy wasn't just mass production and mass consumption. It was a way of organizing the world to solve problems with control as the underlying principle.
Control is central to the design of most systems, indeed to design itself, because broadly stated, we regard good design or good system as one which reduces or eliminates uncertainty. But because of the way we think of human beings, we regard them as an uncertainty. So it follows that we are concerned about controlling human behavior in the whole system.
This is an air transportation system, an airport. The Pittsburgh Airport is the newest in the world. It was built specifically as a hub airport. 2/3 of the passengers are connecting to another destination. Pittsburgh wants to become the River Rouge of airports, the busiest hub on the American eastern seaboard. That means efficiency, hence control in every operation. The airport has the largest baggage handling system in the world, with 6 miles of conveyor belts. The key to the system is the barcoded luggage tag. Thirteen lasers read each tag and route it to the proper conveyor. The system is almost fully automated. No human intervention here. Henry would have loved that. But luggage is only a byproduct of the main material processed through the system. People. The airport is designed to make that happen. Straight lines connect the parking lot to the ticketing area, commuter building, main terminal, and gates. The goal is to get passengers from parking lot to gate in 22 minutes.
The building is not a dynamic system, it's not a machine, but it's nonetheless a system. A system does not require moving parts. One lays out a highway. It's not, without vehicles on it. There's no moving parts in the highway system, but it still has an architecture and there are components that have been assembled in certain ways to respond to certain needs.
Technologies along the way motivate the journey. The People Mover. It can shuttle over 13,000 people an hour. Escalators. Moving walkways.
The airport is one of the most highly choreographed spatial sequences that we experience. The whole sequence of arrival and departure from the gates, going out to the gates, going down to get your luggage, is so highly programmed spatially that if you want to go in the opposite direction, it's virtually impossible. It's so controlled and so unobtrusive that you don't even know you're being controlled.
Other more subtle technologies guide traffic flow. The pattern of the carpeting, the direction of the lighting, even the layout of the tiling.
Since the scientific revolution is that whole notion of the mastery over nature. Again, I think what's happening is that you have the material parts of nature being mastered by these mechanical engineers, being controlled. I think almost without thinking, there's this sense that people are also a part of nature. There is ultimately a mastery over people that becomes part of the mentality of building these marvelous technical systems.
Henry Ford had returned to his roots, the farmer's son, the tinkerer. By then, he and the other systems builders had created the 20th century.